Hi, I'm Deadwood of the HAS2 technical team. We are the developers and organizers of the HAS2 Quals and Finals competition. For HAS2 2020, the top 8 teams from Quals competed in the finals over the DEFCON weekend in a head-to-head race to solve a series of challenges. The challenges involved anomaly analysis and resolution, satellite operations, reverse engineering, and of course exploitation on an engineering model satellite, or Flatset. The Flatset ran a real flight software framework called CFS that was created by NASA and was commanded with the Cosmos command and control software from Ball Aerospace. To up the stress level a little bit, teams were also required to complete the on-orbit challenge, developing a command plan for a live satellite to orient itself to take a picture of the moon while simultaneously continuing to perform in the main hacking competition. For 2021, we're going to take it up a notch. Finalists still had to win their spot by proving their knowledge and skill in the qualifier, but instead of finals being a race to the finish, it is going to be a classic attack and defend CTF, but on a space system platform similar to last year's. Teams will score points by attacking vulnerabilities in the other team's systems. Teams must protect their own system by patching or otherwise mitigating those same vulnerabilities. Teams will get SLA points by keeping their system operating nominally. But this is a space system, and keeping it in the required state might be just a little more involved than ensuring all of its services are running with their intended functionality. The skills that teams need aren't much different or any different at all than last year's. Teams will need to understand architectures and technologies that are used in space systems. They will need to understand operating a system that is orbiting the Earth. They will need to understand communication systems. They will need to be able to reverse engineer at both the system level and also binary applications. They, of course, will need to be able to patch binaries and craft exploits. What is new for this year is they will need to be able to understand the strategy and tactics for playing an attack and defend CTF. The game type is not the only upgrade for 2021. The Flatset from last year is being almost completely rebuilt with new hardware and processor architectures to provide a diverse platform for hosting challenges. The system will include an upgraded command and data handler, or CNDH, an all-new attitude determination and control system, or ADCS, a power distribution board, and a special payload module. The payload's hardware features will provide for a very unique CTF challenge or two. Teams are going to get the opportunity to familiarize themselves with the new flight software ahead of the competition with a digital twin. The digital twin is a system of system simulation of the actual flight software. It runs in a QEMU-based emulator called HOG. HOG extends QEMU by providing a rich plugin API that allows for custom hardware and interface emulations without having to add them to the QEMU baseline itself. For example, it's a HOG plugin that emulates the satellite bus used for subsystem communications, allowing multiple HOG instances running on emulations of various Flatset components to communicate over the plugin without knowing they aren't using the actual hardware bus. Using this digital twin technology allows for distributing copies of the game software to teams wherever they are. HOG also provides a GDB interface, allowing teams introspection into the running emulation, which might prove useful when developing patches and exploits before using them live in the game. Since the finals competition is virtual again this year, teams and spectators both will need access to game information to understand what is going on. In addition to a traditional CTF scoreboard, Flatset-specific telemetry for each team will be visible in real time via instances of NASA's Open Mission Control Technologies. The OpenMCT dashboard is viewable from a web browser and will display key state of health data so spectators can keep track of their favorite team's efforts to operate their satellites while defending it from the attacks of the other teams. Satellites will also be progressing through simulated real-time orbits around the Earth. Spectators will be able to see visualizations of these orbits produced by the Cesium 3D geospatial tool. Not only will Cesium display where a satellite is in its orbit, but it will accurately display a satellite's attitude and orientation. A satellite tumbling in its orbit is probably not in a healthy condition and has probably been attacked. We are excited about the evolution of this year's competition and look forward to seeing the skill, creativity, and tenacity teams will demonstrate to become the HAS2 champion for 2021.